Today we're going to talk about acid rain and the effects it has on our environment. To begin with, rainwater is already naturally acidic, and this is due to carbon dioxide. Whenever carbon dioxide meets water in the air, it can form carbonic acid. And so as an acid, it makes it so rainwater will have a normal pH around 5.6, but it can range from 5 to 7, and this is still called normal rainwater. This is not called acid rain. So just rainwater itself has a normal pH between 5 and 7. This acidity can lead to both erosion and the formation of caves, but this is all kind of the natural, how things always work. Acid rain is more specific. It's rain that has a pH lower than 5. So this is when you get some really bad erosion and formation of caves, even more so. So this can occur when moisture absorbs pollutants. So for instance, you can actually form sulfuric acid, which is a strong acid compared to carbonic acid in the previous example, which is a weak acid. And so with sulfuric acid being formed in rainwater, that's a bad thing. You don't want a strong acid coming from the sky. So in this reaction here, what you see is sulfur dioxide plus oxygen to yield sulfur trioxide. Then sulfur trioxide, whenever it meets water in the air, it forms sulfuric acid. This corrodes metal, paint, and pretty much any exposed surface. Wood, stone, it can be anything. For example, the first two pictures that you see here are two photographs of the same obelisk. They're both in New York Central Park. The first one was whenever it was first made, and then after, you can barely see some of the hieroglyphics that are written on there. Just because acid rain is so badly corroded the stone. I think it's granite possibly, and just completely made it so it's not nearly as beautiful as it was in its former glory. And then also what you see on the right hand side, that actually looks to me like a lot of forests that I saw when I went and visited Yellowstone a couple years ago after they were torn apart by wildfires. Because wildfires just leaves those trees all bare and just burn looking. And if you look, that's exactly what they look like from being hit by acid rain. And so some of the forests, especially those that are downwind of heavily industrialized areas, so that being the northern United States, northeastern United States, they're going to have some very horrible destruction of the forest just simply because of acid rain. You never really think about that acid can burn just as much as a real forest fire. You don't think about the effects that has, but it is actually a very strong effect. Additionally, it's really bad for some of our waterways. So in this example on the top, what you see here is rainwater that acidifies, and then it enters the lake. And as that enters the lake, what's really good is a lot of lakes have calcium carbonate, limestone that's present inside of the surrounding bedrock and all the surrounding stone around the lake. If that happens, it's not a big deal. It's okay for acid rain to enter the lake, because now that calcium carbonate can neutralize the acid that was produced from the rainwater, and it can go on to produce carbon dioxide, just calcium ions and water. So really, it's perfectly fine. The water helps prevent the trees and the surrounding areas and a lot of other destruction happening around the area. But the problem is what if, like the example at the bottom, let's say you don't have limestone present, and instead you have something like granite, which is going to be a very hard rock, and it doesn't have the minerals needed that can help neutralize the acid from the rain. So in this instance, whenever rain enters into the lake, it doesn't have anywhere to go. So now that pH is going to decrease in the lake because your hydronium ion concentration is increasing. So now your water is becoming very acidic. And so all the surrounding plants are going to be affected, as are the animals. The animals will probably just go somewhere else, but the trees, they can't really take root and move. Okay, so it's going to be very harmful. What's even worse, though, is our oceans. So whenever carbon dioxide dissolves into water and forms this carbonic acid that we talked about previously, it can quickly get into our ocean waters, because our ocean waters cover, what, like 70% of our globe? Think about all the carbon dioxide and the carbonic acid, therefore, that's getting into our oceans, because a lot of our big, huge cities are present right along the ocean. And so now, whenever carbon dioxide enters into our oceans, which have an approximate pH of 8.2, they can absorb that carbon dioxide, which is bad because now you're going to have a lot of acidic deposits on the ocean floor, which is going to prevent that carbon dioxide from being re-released back into the environment and therefore neutralizing it. So what's going to happen is carbon dioxide will instead become trapped in the ocean, and now it's going to form different compounds going to be neutralized by anything that has carbonate inside the ocean. Well, the problem with that is a lot of these carbonate-containing compounds are those that are important for survival of aquatic life. So that's your coral reef. Or any shelled organisms. So what they're finding is that the shell on a lot of organisms they're testing, it's becoming thinner and thinner over time. And the coral reefs, that's where a lot of your smaller aquatic animals go for protection, those are starting to be destroyed. And as those slowly decompose over time because of the addition of acid rain into the ocean, that's going to just destroy a lot of the ecology that's present inside the oceans. Now you think, well, that's not really that big of a deal. How fast is it doing it? Well, actually, they're noticing that over the past 100 years, we've had a 0.1 pH drop, and that's just over the past 100 years. Now you think, well, that's not a big deal. But if you project that over time, it's going to get worse and worse. Here is just the concentration of carbon dioxide inside the ocean. So here you can see that it's risen from about 315 to about 390 parts per million. And if we keep on increasing at the same rate we're going, we're just going to keep on destroying coral reef. And until that whole process is reversed, 0.1 may not seem like a big deal, but 0.5 is. So in 5 generations, 500 years, we're looking at some pretty bad effects on our ocean, because right now we're already seeing the effects on life forms, so just keep amplifying that over time, increase pollution, etc. It's going to keep on contributing to acid rain. So what I hope you kind of got from this, I know it's a short lesson, but rainwater is naturally acidic due to carbon dioxide, and that should be a subscript. CO is a subscript 2, with a pH of 5.7. Acid rain, therefore, has a pH that's less than 5. And it's the acid rain that really does the deterioration of any stone, any metals, the ocean, trees, etc. Whereas the hydronium ion can be neutralized in water, but unfortunately in oceans it's coming at the expense of the coral reef and shelled life forms. That's because they do contain that carbonate that's so wonderful coming out of limestone in our lakes, but not so wonderful whenever we pull it out at the expense of our coral reef and our shelled organisms.